Oh, it's okay. Okay, it's okay. Yeah. Yeah. Okay. Yeah. Well, dames and herren, ladies and gentlemen, I hope you had a fantastic beginning of Vue.js Amsterdam 2026. I am super excited to be here. Welcome to my talk. I had a lot of coffee, so I'm pretty hyped. Yes, we'll have another coffee soon in about 20-25 minutes. Well, welcome to this talk. Thanks. In the next 20, thank you. In the next 20-25 minutes, maybe 30 minutes, I want to talk about reactivity in front-end development. I want to tell you why it's become such a hot topic among developers these days and how it has evolved, not just in Vue, but also in other JavaScript frameworks. And of course, the word on everyone's lips these days, well, not AI, because that's the word on everyone's lips these days, but the past years, signals. I want to tell you what they are and how they relate to modern reactivity. I might strongly regret this, but I made a little thing to make this more fun. So if you go to the link mentioned here, rebar.com/live comments, you can send a message and write comments during the talk to ask questions, leave feedback, or make dad jokes if that's what you do, which is fun as well. Please keep it family friendly, and remember the sessions will forever be on YouTube or somewhere else. They are also, I think there's a live stream somewhere. So yes, I see comments coming in. Amazing, 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 amazing. Before talking about reactivity, let me introduce myself. My name is Reza. I am a software engineer based here in Amsterdam. Welcome to our city, by the way, if you come from outside Amsterdam. These days, I do a lot of contracting and freelancing, which is good. You can find me at certificates.dev events as a Vue and Nuxt person for the official certification program. We also have a booth outside. Come by, say hi. We have some discounts and amazing stuff going on. I have also very recently joined the good people of Directus to work on cool projects that turn your databases and backends into shared platforms. I am stoked to be here, back on this stage one more year, and can't wait to tell you about reactivity, which is a fun topic for me. It's my favorite non-AI talk. OK, so let's talk about reactivity. Let's start with a bunch of fundamentals to lay a ground, to lay a foundation, and then add to that. Reactivity is a fundamental aspect of modern web development. It allows developers to create responsive, dynamic interfaces. We know that. It is a system where changes to your data automatically propagate to the UI or other dependent code without manual updates. That's fun. It really matters these days, well, in general, because it keeps the UI in sync with your data. It reduces a boilerplate and bugs that could happen, and it also enables dynamic and interactive interfaces, experiences. Many front-end JavaScript frameworks like Angular, like React, like Vue, have their own systems for reactivity and their mechanisms, but they vary in how they implement it. Let's look at this timeline and see when major frameworks adopted key reactivity systems. The end result for them might be different, but the end result might be the same because they all achieve reactivity, right? But they do it a bit differently. So let's go all the way back to around 2010 when AngularJS introduced its dirty checking two-way binding, which was an early automatic propagation with watchers. A few years later, around 2013, React started with virtual DOM and diffing updates, which was its early foundation, and it had re-renders per state. It was not very fine-grained. It was very reliant on set states and on hooks. Soon, oh, wait, yes. Where was I? Here. Soon after, in 2014, Vue.js introduced reactive data binding and declarative templates with built-in dependency tracking. It was around the same time that Svelte 1 introduced reactive data binding and declarative templates, talked about compile time reactivity, or its initial versions anyway. But in the years after, the Svelte team didn't sit idle, and they improved it a lot in Svelte 3. And they started with modern reactive assignments with compiler-powered reactivity. Skipping to the good part, around 2020, It's when things finally get a bit more interesting. And let's talk about Solid. Solid used true fine-grained signals. What signals are, I talk about them in a second. But Solid did something very interesting there. It tracked dependencies at the smallest granularity. And it meant no virtual DOM, and it meant that it directly updated DOM, meaning minimal overhead, meaning runtime cost being very low, debugging being very good, because it was very fine-grained. About the same time, Vue 3 happened, and it was getting very popular with Composition API around, I think, 2020, and refined reactivity. It exposed reactive primitives like ref, like computed, and it tracked dependencies at runtime via proxies. It resulted in runtime costs being low as well, and debugging becoming kind of easy. At least for me, it was around this time that I got very interested in Vue, and especially coming from React back then, I was like, whoa, what is this? Composition API, let's go. That was very cool. 2021, Astro was introduced. Well, Astro itself, Astro has island architecture. It doesn't have JavaScript by default, but it uses whatever you use with it. Like if you use Vue in Astro, then it has a reactivity system that Vue has. 2022, Quick also had something to say. They introduced fine-grained signals and it promised signals and partial hydration. And finally, Angular caught up in their V16. About time. They integrated signals into the core of Angular, and they had signals-first options. So from 2023 to 2025, 6, you see a kind of a pattern that a trend grows with signals, like Preact, like Solid, like Vue, and signals-based reactivity is widely adopted. So you see how the concept of reactivity has evolved over the years, from the early days with AngularJS watchers to React's virtual DOM to the fine-grained reactivity that we have now with Vue, for example. But the reason that frameworks are putting so much effort, console log please work and do no mistakes. The reason frameworks are putting so much effort in making reactivity mechanisms is that JavaScript is not reactive by default. It evaluates eagerly and once. It has no subscription mechanism built in. So like in this example that you see, if you update your price after total is computed, total value won't change anymore. And this is kind of a no-brainer. That's what we expect from JavaScript. That's what the JavaScript as we know it. Hi to everyone who's saying hi in the comments. Thais, someone is looking for you. But you can make your own dependency pattern, a pattern with subscribers that are a list of effects that depend on a value. You can have a depend method called in the getter of your system that says, hey, I am running now. Remember me. Depend on me. And also a notify method that you can call in the setter and say, hey, I change. Everyone, rerun. A dependency class like this is the heart of Vue's reactivity system. By this, I mean exactly like this. I think something pretty much, let me actually scroll down a bit. So yeah, a dependency class like this is how Vue is doing it these days for the reactivity mechanism. This track and trigger is the conceptual core of every reactive system, like, for example, in Solid, in Mobix, in Signals, in Angular Signals. Frameworks just make it automatic, so you don't have to wire up a depend method yourself. So thank you, frameworks, because it makes my job easier as a developer. So talking about Vue, because we are in a Vue conference, Vue has ref containers. We know that, right? We use it a lot. They wrap any value, like primitives, objects, arrays, anything in a reactive layer, and make them observable. With the first render, Vue records which refs were accessed and says, hey, I depend on you. And later, when the value changes, Vue re-renders the component that depends on it. This is exactly like the pattern we saw in the previous slide, right? That it says it's just built into the core of Vue. It's just built in what a Vue uses. So you don't have to invent it yourself. Just use Vue. Just use ref and compute it. The example that you see here is not pseudocode. The part of code that you see here, Vue's actual ref is essentially this pattern. The dependency class well, the same subscribers, depends, and notifies. From the previous slide is wired directly into the getters and setters of the ref object, which means accessing value during a render in the system, it recurs the effect, and assigning the value notifies the system and reruns all the affected, the records that are affected. Well, of course, Vue offers more than just ref, right? It has reactive. It uses proxy, which I mentioned a bunch of times, and also we saw it in Guillaume's talk, which if you don't know proxies, it's a topic by itself, but just think about objects that wrap other objects, something like that. So reactive in Vue uses proxy instead of getters and setters. It's the same track and trigger mechanism, just a different interception layer. It works for objects, arrays, and more, and it does not work for primitives. We use ref for those, like if we just have a number or something. You don't need to unwrap that with .value like ref, and you just access the properties directly, but well, you might lose the ability to reassign the whole object then. Let's try to scroll down a bit so we see more of the computed. Well, yeah, we know that Vue also has computed, not just reactive and ref. It is a derived reactive value, and it tracks its own dependencies automatically. It uses the same trick and trigger mechanism as ref, but it adds caching. Internally, Vue marks the computed of ref as dirty when any dependency is triggered. And when you read the value and it's dirty, it reevaluates, and it caches the result. When you read the value and it's not dirty, it returns the cache value immediately. Under the hood, it's just an effect with a notify method that says, hey, I changed, so everyone rerun, please. It's just pretty simple. Where am I? Here. OK. Vue recursively wraps nested objects in proxy when you use reactive or ref on an object. This is convenient, but has a cost. Every nested object becomes a reactive proxy, and it will be tracked. If, for example, you have a large data set to work with, this can become costly. Instead, you can use shallow ref to track only the dot value itself. In this case, mutations inside the object are invisible to Vue. Some of the use cases, and if you want to manually force a re-render for a shallow ref without replacing dot value, you can use the trigger ref function. It's useful when you mutate the internals of a shallow ref and you want to notify Vue. But it is time we talked about the elephant in the room. If you have joined this conference before the past years, or if you have been doing any kind of web development lately, you have heard the word signals a lot. I know I have. They relate closely to how modern reactivity systems work, and there's a good reason for that. A signal is a container. I agree, it is a bit cold here. Yeah, thank you for mentioning that. Yeah, thanks for the comments, by the way. A signal is a container. It's a reactive container. It holds a value. It tracks who reads it, but also notifies them when it changes. There are three pillars to signals if you think about the concept. A signal is the source of truth. It is a writable value. The computed or the derived value, which is a read-only value, and it's derived from the signal, the source of truth. And the effect function, which is a function that reruns automatically when the signal dependencies change. This is a complete reactive system. Everything frameworks do with reactivity is a composition of these three pillars, like the source of truth, the derived value from that, and an effect function. This is what all frameworks are doing, well, most of them are doing these days. This looks kind of familiar, right? Like when we're talking about Vue and how it does it, it's kind of very similar, right? This is a complete mental model when thinking about signals. Everything else is just implementation details. Just doing it could be a bit differently. Look at this example. With a signal, you write a value that triggers all that reads it, like count in this example. Computed only reevaluates when accessed and a dependency changed. Otherwise, it's just cached. Effect, which is an auto-subscribe to any signal it reads, and there is no manual dependency errors here with an effect function. One difference here is that unlike useEffect, that maybe some of us are more familiar with that one, you never declare dependencies manually here when you use an effect. The runtime just figures it out automatically by watching which signals are accessed during the execution. So you read signals, signals remember you, and when they change, they find you. Only the parts of the UI that depend on a change signal update, nothing else. This is the core performance win and argument for signals. If you think about an older approach, like the VDOM updates, when state changed, it triggered full component re-renders. So you were kind of working against the grains, against the small bit that only that one needed a re-render. The signals approach says that if my value changes, directly notify only the DOM nodes that explicitly subscribe to that signal, meaning update exactly those parts. In Solid.js, for example, you can create a direct signal with real DOM subscribers, just like the visuals that you see on the right. In Vue, for example, the compiler can optimize templates to create targeted subscriptions. This is why Vue 3's compiled templates are so efficient. This model scales better as apps grow. And because more signals don't mean more re-renders, because each effect only reruns when the specific dependencies change. But why is everyone talking about signals now? Because they are not new. They went mainstream around, I don't know, 3-4 years ago, for a few reasons, I think. Well, Solid.js proved that the model could build production apps with exceptional performance, so thank you, Solid.js. React had developers frustrated for years, as we have seen in the comments. The name React keeps popping up. And with time, bundle size matured and they grew. Well, Signal said, we are tiny, and we don't contribute to a growing bundle size, so it is a win. The key shift with signals was that they are not framework specific, right? They compose very cleanly. You can build a signal system in just 20 lines of JavaScript. They reduce friction, the industry caught up with them, but they have been around for about 15 years. So saying signals are a new invention won't be correct. It won't be fair. Signals have been around since around 2010 with Knockout.js and then with Mobix, if anyone remembers. Maybe the word signal is new, but the idea certainly is not. They are not a library or a dependency you can install in your packages. There is no npm install signals or pnpm add signals, right? They are a concept. They are a model, a pattern or a data layer. It's about implementing a piece of code that tracks changes and updates whoever uses those values. Well, what if I tell you Vue has signals? Maybe the API is a bit different, but the mechanism is identical. The ref is a signal. Computed is derived from that ref, and it has lazy evaluation and caching. Watch effect hook in Vue is an effect that we saw in Signals implementation a few slides ago. So basically, Vue has had signals since Vue 3. Yay! Since around 2020, Vue has had signals, but maybe the namings are just slightly different. Maybe just not directly called signals. Generic signals say I have signal, computed, and effect. Vue 3 says I have ref, computed, watch effect. It's kind of the same for Solid with create signal, create memo, and create effect. In Angular now, these days, I think since V16, it has signals, computed, and effect. Do you see the similarities between the different frameworks these days, that they're all kind of using the same wordings, the same concepts, the same idea behind the mechanisms? It's pretty similar between different frameworks. On top of signals, Vue adds some more cool things. Vue has template compiler optimization, like for example, when you use v-once or v-if, it becomes way more optimized. It has component scoped effect tracking, and it auto cleans up on unmounts. It has suspense and async integration, and it can handle pretty nicely the SSR reactivity. Before wrapping up, let's take a look at the patterns that separate someone who knows Vue versus someone who thinks in Vue. This was made by AI, by the way. This is pretty AI line. Someone who knows Vue, someone who thinks in Vue. Ref versus reactive. The reactive hassle is real, I'm telling you guys. Engineers coming from Vue 2 often reach for reactive out of habit, but I'd say use it only if you need it. If you need it. Otherwise, let's just stick to ref. Computed versus just using a normal function to re-update something, right? This is about performance. Normal functions rerun every time any reactive state changes, because components re-render, of course. Computed values rerun only when their specific dependencies change. So always use computed for derived states. We also have watch effect and watch that we can use in Vue. Well, watch effect runs immediately, and there is no old versus new access, the value access. But with watch, it runs explicit when explicit dependencies change, and you can access the previous values of that, the value that you're watching. So use watch effect for, hey, sync this to that, and use watch for react to a specific change. Vue also has effect scope. Well, Vue uses this internally. Every composable that creates effect should wrap them in an effect scope, so the caller can dispose all effects as one unit. Without this, effects outlive their context, and it leads to memory leaks, especially in SPAs. I cannot repeat this enough. Keep computed pure. A computed property that mutates state is a bug waiting to happen. The reactive graph assumes that computed is a pure function. Side effects inside it break the mental model, and they create update loops, and we don't like that. Well, lastly, having said that signals are a pattern and not a library you install, there are standalone packages outside or out there that you can use to test or actually implement a feature with them. For example, Vue Reactivity or Vue/Reactivity can be used completely standalone, not even with Vue. Like, you can use it for anything. Vue is not required for that. We also have Preact/signals that work with vanilla JavaScript, with React, with Preact. There is an alien signals by the Vue core team that is extremely minimal, but it's very good for experiments, very powerful for experiments. Yeah. Okay, and now I promise it's the last 2 slides before wrapping up, and I would only take 1 minute. Time me if you want. Reactivity, alongside many other topics, are fundamental parts of web development these days. If you want that extra boost of confidence about topics like reactivity, check out certificates.dev. There is now a promotion on certificates.dev that if you purchase a Nuxt or a Vue exam and preparation bundle, you get a free upgrade to a full bundle with bootcamps. So I did some calculation myself. Don't take it with a grain of salt. It becomes like a 50% discount kind of thing. I don't know, I'm just guessing. But if you purchase a Vue or a Nuxt exam with preparation bundle, you get a free bootcamp. The exams are created and reviewed by Evan Yu himself, first of his name, Sebastian Chopin himself for the Nuxt certificates. They're endorsed by so many good people in Vue and Nuxt community that you see here today, or they're talking today. And these are the official certifications that you can get for these programs, for Vue and Nux. There is also React, JavaScript, Laravel, a lot more, but these are the official certifications that you can get and become a certified developer. They also have different levels, so that you can choose if you want a junior, a mid-level, a senior, up to you to find one that suits you. There are quizzes, training materials, specific boot camps, and so much more. And just so you know, all the exams are proctored, so they're all fair for everyone. Come to our booth. We have a lot of stickers. You can collect them all, like the Pokemon from Guillaume. Ask questions. We have cheat sheets. We have discount codes and everything, or find the website. And to match with the theme of the conference this year, we have a new AI platform, because why not? Unlearn that dev is about learning the new ways of development. You can scan this QR code, it gets you there, and it tells you a lot about it. It teaches the foundations of programming and how to create software when AI is part of the stack these days. So we unlearn some of the older methods, and we try to learn how we can use AI more properly, more than just vibe coding. And with that comes my talk to an end. Thanks for listening. Thank you for writing your comments. If you have any questions, please go to Avenue. If you want to get a coffee, find me outside. Jokes aside, if you want to connect or chat, you can find me on socials listed here, mostly found via Rebar. And enjoy the rest of the amazing conference. Thank you very much.